So we're going to talk a little bit about, whoa, what just happened there? We're going to talk a little bit about one-step equations here, okay? But the first thing I wanted to do for you guys is I wanted to let's start with apples. I wanted to kind of try to give you kind of like a an idea here, okay? Um, let's say I have apples. These are my little apples here. This is an apple, okay? I've got two apples here, and and then I have like an equal sign, and let's say, and then we had a number over here, which will make it green, is 12. Okay. Um, so you know, and then if you had an X, okay, like apple times X, I'm going to squeeze it in here, this X here over here. Okay, this is what they call a variable. Okay. Um, so what you do in algebra is you're trying to get everything that's over here on the side of the variable, the X, well, especially at first when you just have what we're calling one-step equations where we're just solving for X, or sometimes they'll call it A or B or whatever. We're trying to get all the apples over here on this other side, so you have X by itself, okay? And so in this case, I've got apple number one and apple number two. So I've got two apples, okay? Um, so how would you get X by itself? Okay, I'm just kind of asking you kind of rhetorically or kind of hypothetically, how do we get X by itself? Well, I'd have to take the apples away from this side here, okay? I'd have to do a minus, and I don't want to draw lemons. That wouldn't make any sense. So, but minus apple here and minus apple here. Okay, so these are all positive apples here. And if I subtracted two apples, if I have two apples and I subtracted two apples from this side, okay. See, I'm thinking this is two apples. So if I took two apples away, I'm now going to have I'm going to have X by itself. I'm going to have X equals something, okay? So I just wanted to kind of start off with that concept that we're trying to get X by itself. And if we have a couple apples on the X side, then we need to take away a couple apples too. Let's say it was five apples, if it said 5X. So we start actually looking like math here. Let's do it like this. X plus 5 equals 10, okay? All right. So in the same way that we just kind of talked about, hey, we're going to take away whatever's on this next to the X, so X is by itself, okay? What do we have on the side of the X here? We got a 5, we got a positive 5. So if I subtract 5 from this side, okay, those two 5s are going to cancel out, right? They're going to be canceled. Plus and minus 5 is just 0. So I'm going to have X by itself. Okay. So that's kind of a basic, half introduction to it. Okay. Just kind of introducing to you guys the idea that first idea is that you're trying to get X by itself. Okay. And, if I was drawing lemons or, if I had three and then these are all lemons here. Okay. Equals, let's say 15. Okay. If this is like three times, like three times these lemons, then I would have to divide, and we'll get into that in a moment. Okay, I'll show you what that means in a moment. So having said that, let me jump to my slideshow, okay? All right, so give me a second here, and here we go. All right, so I just mentioned to you that we're trying to get X by itself, okay? We were just trying to talk about that. So what I'd like you to do is write down in your notes, just example one. Let's just do one at a time here. And I'll kind of walk you through this, to walk you through the math here. So you have 5 plus X equals 9, okay? And then I have a note over here on the far right that says, note, hey, whatever we do to one side, we must do it to the other side, okay? So you might want to give you a few seconds here to write that down, that whatever you do on one side of the equals sign, whatever you do on the left side, you have to do on the right side, and vice versa. And I'll show you what that means in a moment, okay? So I'll just give you a few more seconds to copy that note there. All right. So let's take a look at this. I've got 5 plus x equals 9. And I'm looking at that and going, okay, I need to get x by itself. I want x by itself. So I need to get rid of the 5 that's on this side with the x. So what I'm going to do is I'm going to subtract 5 from this side. And you see my note here? Whatever I do to one side, we have to do the other. That means I'm going to subtract 5 from the other side. So go ahead and put that in your notes, just like I added it there. So you kind of have that step there, okay? All right. Now what I'm going to do is, once I've subtracted 5, I can take my little, you don't have to do this, but you'll get so you just understand it. That cancels out those two 5s. So now I have x equals, okay, because see x is by itself. And then I'm just going to do the math here. 9 minus 5, 6, 7, 8, 4. Okay, that gives me 4. I'm just subtracted 5 from 9. And voila, we just did an algebra problem, okay? We got x by itself. X equals 4. And you can kind of check, if I plug x into the equation, 5 plus 4 equals 9. Well, oh yeah, that makes sense. That's I could have done that in my head, right? But we're showing you how to kind of start doing it algebraically, okay? So let me walk you through another one, and we'll just kind of go through this nice and slowly here. I've got x plus 14. X plus 14 is 29. I see that I want x by itself, and I'm adding 14 on this side. So what is the opposite of adding? Is subtracting, okay? So you're basically, just to kind of add another concept here, you're basically looking at the side with x, and whatever kind of math is going on there, you're going to do the opposite of it to get rid of the 14 or the 5 or whatever it is, okay? Doesn't that make sense? If you're adding 14, then you'd have to subtract 14. So in this case, what I'm going to do is, you can write this down in your notes. I'm going to subtract 14 from this side, and I'm going to subtract 14 from this side. And I'm going to write it right underneath so it's easier for me to subtract, okay? That cancels out the 14 and leaves x by itself equals, do the math here, I got a 5 and a 1, 15. X equals 15. And we can check our work, and we can go, well, if I plug this x in here, 15 plus 14, yeah, that is 29. Okay. So repeat a couple of concepts. We're trying to get x by itself. That's number one. Number two, whatever we do to get x by itself on the side that x is on, whatever we do to that side, we got to do the same to the other side. So if I subtracted 5, I have to subtract 5 to the other side. If I added 5, then I got to add 5 to the other side, okay? All right, having said that, let's just walk through a couple more, and then we're going to get to ones that just are a little bit confusing, or maybe I shouldn't use that word, a little bit more complex, but I'll show you how to do them. Okay, so I have 9 plus x. Okay, so that's a positive 9. So I'm just going to go, I'll let you write this down, by the way. 9 plus x equals 13. And I really would like you if you had several examples in your notes, okay, so that you could go, okay, that's how he did that one. That's how he did the next one. And you can kind of see in your notes. If you're a visual learner like I am, where if I could see it done, the steps, and see it done a couple of times, that's how I learn best. So in this case, I see that it's a positive 9 plus x. So I'm gonna do the opposite of the positive. I'm gonna subtract 9 from this side. I'm gonna subtract 9 from this side, and I'm gonna get x equals 9, 10, 4. Okay. Okay. So that was pretty quick. We're calling that a one-step equation. Okay. I'm going to give you a moment to see if you can just do 2 now by yourself. Okay. I'll give you about, I don't know, 20 seconds. Okay, I'm going to jump in here. Hopefully I'm not rushing you. I see it's a positive 14 plus x equals 33. This is a positive, so I need to do a negative. I got to do the opposite operation on this side. Whatever I did to the left side, I have to do to the right side. So I'm going to write that in there before I forget. That now cancels out the 14s, leaving me x equals, and this is one way to quickly do this. If I'm subtracting 14 from 33, if I subtracted 10 from 33, I have 23. Minus 3 is 20, and then one more is 19. So that's kind of how I do that in my head, okay? X is 19. Number 3 here, if you want to write this down, 47 plus 33 is V. This is almost easier because all you're doing is V is already by itself. So I just have to add these two numbers together, 33. I just have to add them up. So 10, 4, 5, 6, 7, 80. 80 equals V. So V equals 80, okay? And don't be thrown off if the V's on the other side. It just means the same thing. V equals 80 or all right. X plus 19 is 47. I think you know how to do that by now. I would subtract 19 from both sides, and I got the answer. Okay. All right. Let's move on to this is where I wanted to show you where they're going to throw in some of your homework. You might even see it on a quiz. A little bit of a, what's the word, curveball? A little bit of a twist, okay? So go ahead and write down, 9 minus x equals 5 in your notes. And we'll lay out the steps to do this, okay? There are a couple of ways that you could go about doing this, but I want you to really focus in on the fact that you see how it says minus x? So this is like a negative x. That's why there's a little bit of an extra step here, okay? Because we would have an answer, and when we're all said and done, we'd have, if I just subtracted 9 from both sides, and I would have negative 4 equals negative x. Let's just do that like that. So I'm just going to subtract 9 from this side, okay, and 9 minus 9 from this side, okay, just like we've been teaching you. But we're paying attention right here to the fact that it says negative x. So what that leaves me is a negative x equals a negative 4. And how did I get that? Because I have minus 9 and a 5. That's negative 4. Okay. Hopefully that kind of makes sense. The only twist was that this is a negative here. So now what you don't want to have in math, in algebra, is a negative variable or a negative x if you can avoid it. So in fact, the way we would turn this into a positive x, okay, and this is why it's more than one step, just to be honest with you. If I have a negative number and I multiply it by another negative number, it becomes a positive number. So if I had negative 2 times negative 1, what does that equal? That's a negative times a negative. This is a times here. Negative 2 times negative 1 gives me just a positive 2, okay? Because the two negatives makes it a positive, all right? So basically what you'll learn in algebra is that if I have a negative x, if I multiply this side times negative 1, okay, just like I did over here times negative 1, that makes it a positive x. So this would be an x, positive x equals, if I multiply the right side, because we have to do the same thing on the right side, a negative 4 times a negative 1 is a negative times a negative, which is a positive, okay? So that's the bit of a curveball, is that we're doing the same math that we've just taught you in the last slide or so, but if you have a negative x or a negative variable, think of it as multiplying a negative 1 times it. So we can just write this out, okay? I'll just write it out in yellow here. I'll just put this in our notes, okay? Multiply both sides by negative 1. Just because a negative times a negative got me a positive, okay? All right. Let's do a couple more of those, guys, just to kind of solidify that concept in your minds. Okay, so let's do that. Let's take a look at 36 if you want to copy this in your notes. 36 minus x is 11. Right away, I'm kind of paying attention to this. Oh, that's a minus x. Okay, so I'm going to know. I'm going to have to do that kind of extra step. If I get rid of the 36 by subtracting it from both sides, okay, and minus 36 here, okay, that gives me minus x equals, all right, what is 36 minus 11 is 26, 25. And it's a negative then, negative 25, because a minus 36 and a positive 11, you subtract and keep the sign of the greater number, okay? So we're in the exact same scenario. We have a negative x. And so what you'll learn in algebra is you'll learn when I have this situation, you'll actually start skipping the step of multiplying by both sides by -1. You'll just know if I have a minus x equals a minus something else, I just turn them into positive because I know that if I multiply both sides by -1, it turns them both positive, okay? So this would become, I'm going to just draw an arrow here, do that to this side, this one here, and we're going to do the same thing to this one here, okay? So if I multiply -1 times the negative x, a negative times a negative is a positive. So I'm going to get an x. And if I multiplied a -1 times a negative 25, gives me a positive 25, okay? So that's how to solve that little curveball. 3's easier. 47 minus 23 is v. Oh, I'm just going to do the math. I'm going to put 23 over here. And I'm going to get a 4 and a 2. So 24 equals v. Okay, there's my answer. If I circle it, 24 equals v. Somebody might go in, hey, teacher, you subtracted 23 on this side. Don't you have to do it on the other side? No. Here's why. Because the variable, v in this case, is already by itself. Remember, we were doing that operation on the side of the variable because it wasn't by itself. In this case, it's v equals whatever this little math operation equals, okay? That's why we didn't do it to both sides, in case you were wondering, to clarify. All right, a couple of these are pretty easy. I'm going to turn you loose. See if you can do 4 and 5, and I'll pause my recording here. See if you can do 4 and 5 on your. Okay, I'm gonna jump in here. Hopefully number 4 was fun. Hopefully you're going, hey, I'm starting to get algebra. But I'll show you kind of how I would have done number 4 here. I have x minus 14 equals 48. You see how it's a minus 14, okay? What's the opposite operation of subtraction? Adding. So if I added 14, okay, if I'll just put a plus 14 to this side and a plus 14 to this side. See how that's minus, so the opposite is to add. That cancels out the 14s and leaves this x by itself equals, I'm going to count up 48, 58, 59, 62, okay? All right. X equals 62, and I hope you came kind of close to that, okay? Doing the next one, which we kind of just got through talking about. I'm looking right away and I go, oh, I've got a minus g here. I'm going to have to remember how to do that little extra step. But if I subtract 58 from this side and subtracted 58 from this side, I'm thinking already I'm going to have a negative number over here on this side because 58 is bigger than 26 here. That cancels these out, these 58s, and that leaves me a minus g. And don't forget to put the minus there, equals 58, 48, 38, 32, okay, minus 32, okay. I'm going to double check 58, 48, 38 minus 6 is 32. Okay, so I've got a negative g equals a negative 32. And we just remembered the rule that we just taught that if I multiply both sides times, I'm just going to again multiply both sides by -1. Okay, so if I multiply a negative times a negative, negative g times a -1, that leaves me a positive g equals, and a -1 times the -32 gives me just a positive 32. Okay, now it just occurs to me that somebody might be thinking, hey teacher, how come we didn't like write that step out? I could have, but I just wanted in these one-step ones to try to keep it as simple as possible visually, especially as I send out my slideshow. Okay, I'm going to move along a little bit here. Again, 93 minus, I'm noticing the minus variable. So I'm going to subtract 93 from this side, and I'm going to get a minus W equals 93 minus 40. What is 93 minus 44? What does that equal? Did the math real quick. 8, 13, that's a 9, and that's a 49, and it's negative 49. And so here's the point where your mind will just start jumping. Okay, you'll just know, okay, I know if I multiply both sides by -1, I'm going to get, this should be a W here, guys. Sorry, there should be a minus W. Minus W. I know if I multiply both sides times -1, that just turns the minuses to pluses. So I know W equals 49. Okay. You will just start doing that almost without thinking of it later on in your math career. Okay. Okay. I'm going to pause this and let you take a moment to copy down everything that's on this. Okay. I hope I gave you enough time here to kind of copy down some of the ideas here, but it says one-step equations now with multiplication and division. Okay. Isolate the variable. Isolate means getting the variable by itself. That's what that means. To isolate is to get it by itself by doing the reverse operation, for the given equation. Okay. Now back in review, remember I said if I had x plus 5 equals 15. What's the reverse operation of plus 5? Was to do minus 5. Okay, now likewise, if I have 5x, which is actually what I have here, whenever you see 5 times x, this is like the times, sometimes it would be written like this, 5 times x. Okay, or sometimes they'll write it like this, 5 and then in parentheses x. Okay, when they're right next to each other side by side, that means they're multiplied by each other. Okay, so I'm going to kind of rewrite this, and you might want to do this. 5, this is 5. That's that little asterisk, by the way, is kind of the way we make the times symbol on a computer sometimes, so it doesn't look like XX. Okay, extra large. 5x. So I'm just going to rewrite this as 5x, because that's 5 times x equals 77. Okay, that's the same thing as just 5 times x. All right. Now, it just said that we're supposed to do the reverse operation here to get it by itself. What is the operation that's going on the side of the x? Okay. Is it addition, subtraction, multiplication, or division? Those are your 4 choices. It's multiplication. We're multiplying 5 times x. Okay. So if x was 2, 5 times 2 is 10. If x was 5, then it's 25. So in this case, it's multiplication. What is the opposite operation? Is division. Now, watch how I do this, and I'm going to change color just to make sure it visually shows up. So I see that I'm multiplying. So to get rid of the 5, I'm going to divide it by 5. Okay. Now, why did I do that? Because you know that if I had 2 over 1 divided by 2, okay, from when we did fractions, 2 over 1 divided by 2 becomes divided by 2. Okay, you take that one on the right, the number on the right, and you go like this. You go 2 over 1 times the reciprocal, which is 1 over 2, and then you would get 2 over 2 by multiplying, and that just equals 1. Anything on top of itself is 1. Okay. So likewise, I know that if I have 5x, if I divide this side by 5, okay, I turn this into 1. That cancels out the 5s. Does that kind of make sense? Okay. If I have 2, okay, and I divide it by 2, it ends up canceling out the, really that becomes, what is 2 divided by 2? It really looks like this, okay, equals 1, or 7 over 7 equals 1. So if I divide this side by 5, I cancel out the 5s. So whatever I did to the left side, I've got to do to the right side. So whoops, I just wrote a minus. I'll just make this into a funny looking 5 here. That's a 5, okay? So I'm dividing this side by 5. Did the same thing. Now here's what that does. I'll just kind of write this out. That cancels out the 5, and really what it becomes is 1x in a sense, or just x. 1 of x is just x by itself. X equals, and then I've got kind of a odd thing there because I got 77 divided by 5. So I'm just going to 77 divided by 5 equals 15.4 on my calculator, because 5 doesn't go into 77 cleanly, okay? So it's 15.4, okay? All right, notice we're kind of throwing a decimal in there, but that is how we get rid of, when we're multiplying on the side of the x, what do? We do the opposite. We divide to get rid of it, okay? All right, so let's look at example 3 next, okay? Because I want to reinforce what I just taught you, okay? I've got 11 times x equals 99, okay? When you see that, it might be simpler, like I did previously, to just go, oh, that's just 11x. Okay, that means 11 times x equals 99. Okay, and then what operation do I need to do, since I'm looks like I'm dividing, I'm multiplying, okay? Reminder on my slide, whatever we do to one side, we must do the other. What is the math going on the side of x? It's multiplication, right? How do we get rid of multiplication? By dividing. That's the opposite operation. So I'm going to divide this side by 11, and I'm going to divide this side by 11. And this will be nice and clean. And that is going to give me, that's going to cancel out the 11s and make it basically 1, which means I just have 1x, or just x, equals 9, because 11 goes into 99 9 times, okay? So that's an example of using the kind of what they call the multiplication principle of, all right, let's take a look at this next one though. Example 2, because it's okay. It's division. How would you think logically you'd get rid of division? Opposite of division would be to multiply. Okay. Now it's probably best for you, whenever you have like x divided by 9, to rewrite it as this: x over 9 equals 12. And I'll show you why here in a second, okay? So that means x divided by 9. It means the same thing, okay? Now, we have division going on. What's the opposite? What is the opposite of division? Is to multiply. Can you guess what I'm going to multiply this side by? What am I going to multiply this side by to get rid of the x? Okay. Hopefully you're thinking, oh, if I multiply 9 over 1 times this side, okay, see what would happen? These two cancel out, and I'm going to have x over 1, or just x, okay? So whatever I did to that side, I'm going to do times 9 over 1. Okay, just go ahead and copy it, and then we'll slow down and digest it a bit here, okay? So again, backing up, at the start of the problem, I saw x divided by 9, and I told you, turn that into a fraction, because it'll be a little bit easier visually to see how to do it as we try to solve it. All right, so I know that this side the side with x has division, and the opposite operation of division is multiplication. So I had x over 9 here. So I multiplied 9 by this side, because I knew that 9 times 9 over 1 times that, if you did, if I was cross canceling, this would be a 1 and a 1. So I'd have x over 1, which is just x. Okay. That gives me x, okay, that cancels out these 9s here. If I, here, I'll just even visually draw this through. That gives me x equals, let's do the math on the other side. These are 1s, so what is 9 times 12? I kind of forget. Yeah, that's terrible. 9 times 11 is 99 plus another 9 is 108. That sounds about right. 108, okay. 9 times 11, 99. 9 times 12 would be 9. No, 9 times 11 is 99. Yeah, so 108. Yeah, that's right. Okay, so yeah, I just did whatever I did on the left side, I did to the right side, okay? And that left me with x equals 108, okay? Now, I bet you some of your brains are a little bit stretched right now, so let's reinforce a little bit. Let's do a couple more just to kind of keep the idea going. Okay, I'm looking at number 3 here. You can copy down 47 times, that's our little computerized time symbol. 23 equals v, okay? And I see, oh, v's, the variable's already by itself. So I just have to do the operation on the left side and then I know what v equals. And so, you know, in this case, you can do it the long way, or you can punch it in your calculator and just go 47 times 23, and you will get 1081, okay? 1081 equals V, which is the same as saying V equals 1081, okay? All right, let's look at number 4 here. You got X times 14 is 322. My brain is starting to catch on. This is times, right? This is the time symbol. What is the opposite? Is to divide. So if I divide 14 on this side, then I have to do the same thing on this side. I'm doing the opposite operation. That leaves me, these canceled out, these 14s canceled, leaves me x equals 322 divided by 14, and that gives me 23, okay? Did that on my calculator. All right, let's look at number 5. If you want to copy down that, 58 times g is 232, okay? Now, for that one, I'm just gonna kind of give you a, you know, again, I've mentioned this to you before, 58 times g is just the same as 58g, okay? It's just 58g equals 232. And then visually, it kind of makes it just a little cleaner in my mind as I think about that. How I've done multiplication here. Here's the time symbol, okay? How do I get rid of something that multiplied by the variable? By dividing, by doing the opposite. So I'm going to divide this side by 58, and I make sure I write it over here on the other side before I forget, because I don't want to forget that whatever I do on the left, I have to do on the right. That cancels out my 58s, and that gives me, different color here, gives me G equals 232, right, divided by 58, and that gives me 4. If I did that right, it gives me 4, okay? All right, so those are a couple of just more examples. I hope you're starting to get it, but I'm going to continue on with some more notes here. So, okay. What I'm going to do with a couple of these is just start them. I'm not going to complete them. All right, so I have 36 divided by x. Do you see that? I would rewrite that as 36 over x equals 6. And then what I do next, I would go, okay, if I multiply, let's see here. This one might turn out to be a two-step one. Again, I'm just thinking out loud that if I multiply 36 over x, if I multiply both sides by x, okay, x on this side over 1 times that, and I multiply this would be 6 over 1, or 6 times x, okay, this x. Okay, the reason why, by the way, if you're wondering, hey, how come you didn't multiply by 36? Here you got 36 over x. because I'm trying to get rid of this bottom thing, okay, the division here. I'm doing multiplication to get rid of the division here, something that's underneath something in a sense. So what that does is cancel out these x's. Okay, you kind of see that that would cancel out my x's. I'd have x, so I'd have 36. That leaves me 36 equals, and then I've got 6 times x here. See, 6 over 1 times x, which is just 6x. This, I better draw an arrow over here, folks. Sorry. Okay, squeezed it in here. So I multiplied x by both sides, and so I have 36 equals 6x. Okay, I'm going to rewrite it here just to, so it's 36 equals 6x. At this point, it's a little bit easier to do now because it's, oh, if I divide this side by 6, it's because here's the side with the variable, and I've got multiplication going on here. Opposite operation is division. Divide this by 6, and that leaves me a canceled out 6 with x equaling 6. Okay. All right, let me just start the next one, and then I'm going to keep moving on my slides here. 45 divided by x, I'm going to go like this. 45 over x equals 9. Okay. And then what I would do, I guess I'm going to do a little bit more, sorry, is I would I want to get rid of the division here. See, this is division going on. What is the opposite operation division? Is to multiply. And so I'm going to multiply x over 1 times, that's the times symbol. And so I got to multiply this side times x, okay? I'll write this little dot here, times x. And that will leave me 45 equals 9x. These x's canceled. 45 equals 9x. I guess I'm doing the whole thing, aren't I? Yeah, I am. Now to get x by itself, I see that 9x, 9 times x, this operation is multiplication. Get rid of multiplication by doing the opposite. Divide by 9, divide this side by 9, and I get x equals 5. 9 goes into 45 5 times. Okay, that would be my answer. Okay, I think that's enough of those, but I hope you're starting to get it. But most importantly, I hope that you've got the notes. You've kind of copied down the steps, okay? And you're starting to kind of see how I did these, and you can refer back. I will just, again, get you started on number 4 here at the top of the screen here. I've got x divided by 7 is 49. And I've now said a couple times, anytime you have divided by like that symbol, I would write it as x over 7 equals 49. And then this becomes a little bit maybe even easier now to see here. If I multiply, okay, if I multiply 7 times this side, because I'm now canceling out the 7s, and I multiply this side times 7, okay? 7 over 1, if you want to. What that does is cancel out the 7s. So I'll just choose red here. Cancels out the 7s, and that leaves me x equals, clear, all clear. 49 times 7 is 343. 343. Okay, I think I've done enough to kind of give you the general idea here, okay? Let me see what else I have, though. I want to make sure I cover all my concept. Yep. Oh, here's 19 plus x. Oh, we're back to the pluses. Those are easy, okay? I would just go minus 19 here and a minus 19 here. And that leaves me x equals, this becomes a 1, 7, 9. What is 17 minus 9 is 8. Yeah. And then 1 minus 1. So x equals 8. Okay. So, and then the next one, 108 minus x. Oh, yeah, we did some of those. I'm going to subtract 108 from both sides and get a minus x equals a minus number. Multiply each side by -1, and it gives me x equals whatever that positive number now is. Okay. All right. How are we doing here? Number 8, just to visually show you, it says 144 divided by 12 equals x. Oh, x is already by itself. X is already by itself. So let's just do the operation on the other side. 12 times 12, yeah, 144. Claire's, I should know this. 144 divided by 12 equals 12. Yep. 12 times 12 is 144. So this is just 12 equals x. Okay. X plus 248 equals 629. Don't be intimidated by those big numbers. I have x plus a number. Opposite operation of plus is to minus the same thing. And that will be minus 248. I'll stop right there. You guys can go from there. You would know what to do next, okay? X minus 473 equals 904. Opposite operation would be to add 473 to cancel that out. So add 473 to this side here. This is a plus here, okay? And you can solve it from there. I hope you're starting to get this. I hope it's starting to kind of make sense. I would take number 11 here, okay? I would take number, I have x times 7. I would just write it like this, okay, on my paper, because it means the same thing. 7x equals 112, okay? It's the same thing, okay? And then what I do next, hopefully you guys can figure that out. You go, oh, this is multiplication, 7 times x. Opposite of multiplication is to divide, and I can stop right there, okay? You guys can get it from there. Number 12, x divided by, I think we are almost done here, guys. X divided by 24. Okay, teacher said, write the division one as a fraction. X over 24 equals 552. And then from there, okay, how am I going to get this x by itself? If I multiply this side by 24, 24 on this side, over 1, times that, okay, and do the same thing over here, times 24 over 1. That would cancel out my 24s and give me x equals some big, huge number, okay? 552 times 24. Okay, give you a moment, copy that down. And that's it. All right, what I'm going to do is, hopefully if you have any questions, you can email me and let me know what your questions are. Hopefully this has been a real clear explanation and you'll just sail through your homework, okay?